Our first instruction today is to inscribe. So yesterday we looked at circumscribing, and with circumscribing we were trying to put a circle around the outside of a figure. With inscribing, we want to put a circle inside of a figure. And we want to do so in such a way that the circle is tangent to each of the sides of the figure, so that it just brushes along each of the sides of the triangle. Mine looks fairly equilateral, but I didn't really measure anything. It doesn't matter what kind of a triangle you do this for. The process is the same whether it's acute, right, or obtuse. Okay? And by the way, when your problems say something like construct a right triangle and circumscribe or inscribe, or construct a square and circumscribe or inscribe, you must actually do that construction. Okay, don't just draw what looks like a square to you and use that. You actually need to go through the process of constructing it to make sure that it is, and then going on and putting the circle inside or outside or doing whatever you're doing with it. Okay. So to do our inscribing here, our first step is going to be to bisect at least 2 angles. So yesterday we learned to circumscribe, to put a circle on the outside. In that process, we bisect sides. When we circumscribe, we bisect sides. When we inscribe, we bisect angles. The way I try to remember it is by really trying to emphasize to myself the in, and the angle has an in it, okay, and sides do not. So when we inscribe, we do the angles, okay? When we circumscribe, we do the sides. Again, you only have to do at least 2 of them. If you do all 3, they should all intersect at the same point, so that gives you kind of a way to check your accuracy on that, but you don't have to. So to bisect an angle, you put your compass point at the vertex of the angle and make an arc. Then you're going to put your compass point at one of the places the arc meets the side of a triangle, and we're going to make an X. Now, like yesterday, that I like to set my compass really pretty big and make it so my X happens outside. And the reason I like to do this is there's going to be a lot of stuff going on inside of this triangle, so if I can make some stuff happen outside, that's going to make it a little bit less cluttered and messy on the inside of this thing. Whoa. Okay, and then you get one angle bisected, and then we need to do it again. So pick one of the other 2, doesn't matter which one. And you can actually do all 3 if you want. So I make a mark across the other angle I want to bisect, and then I'm going to open up my compass again pretty wide so that when I make my next marks, it's going to happen outside of this triangle. I don't know. We'll see how good it is once we finish the problem. It looks pretty good, but I don't know. If you go, actually I can tell it's not very good, because if I bisect that next one, I can tell I'm going to miss.
Please back up into the extra office.
So if you do all 3, they should all intersect in the same point. If they're like really close but not perfect, sometimes I cheat and just make the point a little bit bigger. But if they're like really far off, I mean, you can't have a dot that's like, you know, the size of your thumbprint, right? So You can kind of do that third one if you want as a way to check your accuracy, but you don't have to. You only have to bisect two angles.
Do you even need to do that first arc to do it from the 2 points? Can
Yeah.
you just do it from the other 2 vertexes?
No, because they're not necessarily equally spaced. The reason why we do the arc is to get something that's equally spaced on both sides of the vertex. So if it was truly an equilateral triangle, then that would be fine. But when we don't really know and I just kind of randomly made those segments, that wouldn't quite work. Good question though.
Sometimes make the dots kind of big.
Yeah, I mean, kind of big, not like fingerprint size big. So that's going to be the center of our circle. And then we need to figure out how wide to make this circle. The circle is supposed to be tangent to the sides of the triangle. What do we know about a tangent to a circle?
It touches at one point.
It touches at one point and
It's perpendicular.
perpendicular to the radius. So what we're going to do now is make a perpendicular from that point to one side of the triangle, and it does not matter which side. So this is our boat construction. So I'm going to put my compass point on that place where I found the intersection and make a boat. And then from each side of the boat, make a mark.
If you do the boat underneath.
You can do it to any of the three sides, but from the point, make a boat to one of the sides. I just did it to the bottom side. And so you can tell it's not quite perpendicular there, but that's the idea.
You can make the line perpendicular.
And now to actually get our circle inside of this thing, we're going to put our compass point on the center point and pencil where the perpendicular meets the side and draw our circle and cross our fingers because it is not usually very perfect. I'm actually surprised at how decent this one is, given how bad I can tell my first things were. It should just brush each side. This is actually something where I would maybe even accept this. Like, it's not by any means perfect, but the longer these problems get and the more steps that are involved in them, each step we do is going to have a little bit of error in it. And then when you go and do the next step, there's going to be a little bit of error there, and then a little bit of error in the next step. And by the end of the problem, all these errors accumulate and things get not so perfect. So as you're doing your assignments, always please feel free to ask me and say, like, is this good enough, or would you take off any deductions on this? And I will let you know, like, I think that's fine, or you should maybe try that again. And sometimes if you're borderline on it, I'll make a call, and if I say it's okay, I'll actually write in your notebook a note to myself saying that I already approved it so I don't forget and take off points on you. But always feel free to ask. It should, if done really well, brush just exactly perfect each side of the triangle. So mine hits one side, and then it's kind of out on one and in on the other. If it's done perfectly, it should just brush against each side. Our second construction for today is to do proportions. So when we studied proportions, a proportion is a fraction equal to a fraction. So our problems are going to look something like a over b equals c over x. And then they're going to give us 3 segment lengths. Now when you do your problems, you'll kind of get to choose how big you want your segments to be, but maintain the same as what the worksheet says in terms of small, medium, and large. Okay, so on your worksheet it actually says using A, B, and C, and it gives you some segments there. You don't have to perfectly use the same lengths that are on the assignment sheet, but keep the same idea of small, medium, large. Okay, whatever one is the smallest one, make sure that's still the smallest one in that idea. Okay. Now, we're not using rulers. Okay, we never use a ruler to take a measurement in constructions and find out how big something is. But just to kind of explain to you what we're trying to do in this problem, I'm going to pretend like we're using a ruler and show you what we're going for here. Okay, so let's say I used a ruler and I found that A was equal to 4, and B is equal to 7, and C is equal to 5. Okay, so I measure those out in a ruler and I find out that's how long those are. What we are trying to do is find how big x would be so that it meets these fractions, so that a over b is equal to c over x. So our answer x is going to be a segment of some length, and we're trying to find out how long that should be. So how do we solve a proportion? Cross multiply. So we get 4x equals 35, and x is 8 point something, a little bit smaller than 9. If we were using rulers, that's kind of the idea we're going for here. Okay? But we're not using rulers. So what we need to do is, by construction, find out how long this segment should be. Okay? Our first step in doing that is going to be to make an acute angle with very long sides. Make an acute angle with very long sides. It doesn't matter how big the angle is in terms of degrees, but you're going to want long sides to work with. When we studied proportions, we studied them with similar triangles. So what we are going to do is create some similar triangles. We are going to use our compass and put the point at one end of segment A and put the pencil at the other end of segment A so that our compass is open kind of A wide. And we are going to mark that on the top line, so that this length right here is A. Okay, so I put my compass point on one end of A, compass pencil on the other end of A, and mark out that length along the top side of that angle. I started with A because in our problem, the problem we're trying to solve up here, A is the top of the fraction. So you start with whatever the first top is. Then we're going to do whatever the bottom of that one is. So we're going to take our compass, point at one end and pencil at the other end of B. And we're going to mark that out from the end of A, not from the corner of the angle, but so that we have A and then next to it we have B. And then likewise, we're going to use our compass to figure out how big C is. And we're going to put C on the bottom. So we're building these fractions along the two sides of the angle. So we put A, and then next to it we put B, and then on the next one we put C, and next to it should be X. But that's our question, is how far is that? How far do we go to find X? No. So when we study these proportions, we studied them with similar triangles. One way to make similar triangles is to first start by connecting the end of A to the end of C so that we have a triangle. And we're going to stack this inside of another triangle. And the two base sides should be parallel. That was something we learned about back when we learned about similar triangles. So if we have these stacked triangles, the third side of them are parallel. So we're going to make a parallel. First step we just did there was connect ends of first segments. And what we want to do now is make a parallel at the end of B to that blue line. So I grab my ruler, I can kind of eyeball what we're going for here is we're trying to find kind of this line here that would be parallel to the other one but going through the end of B to close off and make a bigger triangle stacked on top of that smaller one. Okay. So we learned two different ways to make parallels. We learned to do two sets of perpendiculars, or we learned to do angle copy, and I said it really doesn't matter which one you do, and that's true. They both work. Sometimes one is a lot cleaner than the other. So I'm going to strongly suggest that no matter what your normal inclination is for making them, that you go with angle copy in these problems. You can definitely do double perpendiculars if you want, but there's already a lot of stuff going on in these problems, and doing double perpendiculars is going to make this problem pretty messy, whereas an angle copy will be much cleaner. So what we're going to do now is make a parallel at end of second segment. So to do that, I'm going to use the angle copy method. So for angle copy, I'm going to copy that angle that is made by the top purple line and the blue line, because that's the line I'm trying to go parallel to, is that blue line. So to do that, I use my compass and I put an arc across there, and I put the same size arc where I want my new angle to be. Okay, so I put an arc. I put my compass point where the blue and the purple line meet on the top, and I made an arc, and then I made the same size arc from the end of B.
Where do you put your compass? On the second one.
At the end of B. So first, my compass point is here, and I make an arc, and then my compass point's here. So at both ends of B is where we're making the arc, putting the compass point. Then we use our compass to measure how wide that arc is from this point to this point. Okay, so we're measuring how wide that angle is across that arc. So we use our compass, point at one end, pencil at the other, and then we measure off that same distance onto the other arc. And that gives us a point to connect through. So then we should have a parallel line coming in there. Actually, amazed, mine does too.
This is all just to solve that proportion.
This is our second to the last construction. So, as we move forward, the things we did in the first day only had a couple steps, and as we move forward, they get longer as we go. But this is our second to the last construction that we're learning. So that, yeah, there's a lot that goes into it.
So after we're done learning them, what are we gonna do?
After our next unit.
Don't we have like a week before it's due?
That's for people who have gotten behind. Me being behind. So in terms of our answer then, the answer to this problem is the length between the parallels along that second segment. So in terms of coloring your answer, kind of what's colored in green there is what you would need to color. That's what we're looking for, is the length of the segment that would meet that proportion. So our last step is that x is the length between the parallels on the second line. Okay. So the reason why this works, back when we studied similar triangles, we learned that in similar triangles the sides are proportionate, so that we could set up these proportions of like first part of top to second part of top, first part of bottom to second part of bottom. And we set these proportions back in chapter 7 and solved them with numbers and x's in the problem and stuff. So now we're using our compass to create these similar triangles that we could solve them. Okay. You have 3 of this type of problem in your assignment. The first one is exactly this problem. A over B equals C over X. Okay, so you're going to do the same exact thing. Okay, first problem is the same exact thing. The second 2 problems require a little bit of algebra to be able to solve the problem first. So I want to go through with you the algebra on those, and then you'll still need to do the construction, but I want to set up the algebra with you so we're all on the same page there. So one of them says x is equal to AC over B. This is not a proportion because it's not a fraction equals a fraction. It has a fraction on one side, not on the other side. Also, we can't do the construction when we have 2 things going on top of this fraction. So there's too much going on the top of that second fraction. So how can I get rid of something from up there? I can multiply by something. So let's say I wanted to get rid of C. What would I need to multiply by to cancel that C? If I want to cancel by C, that's going to give me more C's. I want to divide by C or multiply by 1 over C so that it cancels the extra C. So then over on the left, I'm going to have x over C because that's like x over 1. So I multiply, we get x over C equals A over B. So now it's a proportion and it's looking good. But when we go to build those, we're supposed to do the top. But I can't do the top if the top is x because I don't know how big x is. So one of the things we learned about proportions is that you can flip them over as long as you flip them both over. So I'm going to flip this thing upside down and backwards, make it B over A equals C over x. And then you could build the problem that way. So then when you build it, on your angle you would build out B, and then A, C, and then solve for however big x is there. The last one of this type of problem on your assignment says that x is equal to b squared over a. Okay, so they're not both fractions, so we can't solve this. It's got a b squared in it. What does b squared mean?
B times B.
B times b. So now, like the last problem, there's too much going on top of this fraction. How do I get rid of one of them? Divide by it, or multiply by 1 over b. So that leaves me with x over b equals b over a. Once again, the x is in the wrong spot. It's supposed to be on the bottom of the second one, so I'm going to flip this thing upside down and backwards.
Give me 2 B's.
And you're going to need 2 b's on this one and no c's. So when you go to build this thing then, you're going to build out a and then b, b, and then find x. And you won't use c at all because there were no c's in the problem. Okay, so you'll use b twice and no c's.